Hey everybody, Mr. Ranger here. Today we are going to talk about Bohr diagrams, or an introduction to Chapter 4, Section 3. So, Chapter 4, Section 3 has to deal with modern atomic theory. Modern atomic theory. And while we won't be going into everything about this modern atomic theory, we're just going to get a brief overview of at least the start. So you guys hopefully remember, or you still have the notes from section 2 where we drew an atom diagram. We went through the structure of the atom, we talked about where pieces were in place, and then we drew the atomic diagram. In our example that we had in this class anyways, we chose carbon from the periodic table, and we noticed that there are 6 protons on the inside, and it looks like there's 6 neutrons also on the inside of the nucleus. And then I had you draw these circles with these E minuses representing electrons. And I told you that it was a Bohr model. We probably didn't think much of it, we didn't talk too much of it, it was just, that's what we labeled. And we went through the parts of the periodic table, figured out how to find them, and noticed that this matched up with this and this over here. So today we're going to talk a little bit about Bohr's model. So Niels Bohr was a physicist that came up with the next wave of changing our models of the atom. And what he decided is that as we went through Rutherford's experiment, where we found the positive center of the nucleus and it had electrons, we actually found these electrons are found in certain energy levels. All right, so in the Bohr model, we have electrons can be found in certain energy levels. All right, so we revolutionized what we thought atoms and how they are arranged inside of elements. We went from the Democritus model, where things just couldn't be broken down. Then we went into the Thomson model, where things look like plum pudding, where we had electrons in an atom with the positives throughout. Then we went to the Rutherford model, where we had a nucleus, positive nucleus with electrons, and then from the Bohr model, where these things can be orbiting around it. All right, so we came up with this idea through eventually the electron wave model, but through this uncertainty principle. Uncertainty principle that if you know where an electron is, you can't know how fast it's going, and if you know how fast it's going, you can't tell where it is. All right, so this uncertainty principle says you cannot know both the speed or location of electrons in a orbit. Okay, so you can't know both the speed or the location, just because that's the nature of the whole idea. If they're in an energy level, these electrons are orbiting these atoms or these nucleuses, and if they're orbiting in a circle and they're traveling in these circles, you can't know exactly where they are and how fast they're going, because if you use it like a picture and you take a picture of that, well, if you take a picture and you know, okay, I know exactly where it is, but then you don't know how fast you're going, is because you took a picture of it, and that's the basis of the uncertainty principle. All right, what we do know is that in the Bohr model, electrons are located in what we call orbitals. And this sounds like orbits because the idea was in the Bohr models that the electrons orbit around the nucleus in these nice little areas. They were calculated by Bohr and other scientists, and they are shown in diagrams in these shaded areas or in these circulars. There are 4 types of orbitals that we're going to talk about. 4 types of orbitals. and they all have labels. Okay, so they're going to be called, they have S, P, D, and F. Why they chose those 4 letters, I have no idea, but those are the regions that we're going to find these things. Okay, so they're not, now in these 4 types of orbitals, they are not based on location. But actually they're based on the energy. Therefore, every orbital has a certain amount of energy associated with that orbital. Okay? And only so many electrons, fit in each orbital. And we can calculate that, actually. All right? So, to calculate the number of electrons in each orbital, it follows a formula. And I'm going to add this out here, and I'm going to draw this out just so that everyone can see it. So what you're going to need is you're going to need to have some space here to add it to. So we're going to write the amount of electrons per energy level is equal to 2n squared. All right, with n is the number of energy levels. All right, so what we're going to do is we're going to make ourselves a little t-chart, and you're going to, like I said, you're going to need some space here. So if we have the energy levels, and that's going to be represented by n. We'll make our t-chart, and this on this side is going to have the number of electrons. Okay, so in our first energy level, following the formula over here, if we put a 1 in here, 1 squared is 1 times 2 is 2 electrons in the first energy level. Go down the list. In the second energy level, 2 squared is 4 times 2 is 8. Remember to follow your order of operations. You have to square things before multiplying. In the third energy level, 3 squared is 9 times 2, 18. And just for fun, we'll go 4 squared, 16 times 2 is 32. All right? So you can fit this many electrons in each model. All right? Now, some things to note here for the Bohr model is that, I guess we can add it right here. When we're building Bohr models, that we have to fill from the inside out. We're going to add a new piece of paper here. I'm going to slide this up a little ways so you can look at that. Okay. So some special notes here is that when we're building Bohr models, first thing that we have to consider is say we're going to build or fill orbitals from the inside out, which means that we are always going to start at number 1 energy level and make our way down to 4, 5, 6, or whatever else that we need. We have to start from the inside and then we'll work our way to the outside. 2, only fill to the max, then go to the next level. Okay, you can fill it to the max. So this on this side is a maximum number of electrons, a maximum number of electrons that can hold. If you have more than 2 electrons, you have to put 2 in the first and then the next ones in the second level. And I'm going to show you an example. All right, so let's go back to our idea of carbon. All right, so we're going to do carbon. All right, we're going to fill in the center dot. That's going to represent the nucleus. Now, carbon on the periodic table, I had one sitting close to me. Carbon on the periodic table, oh hey, look at that, we can use this. Carbon on the periodic table is 6 on the periodic table. Our atomic number is 6, and we know that our atomic number is the same as the protons, and the protons are the same as the electrons. So we have 6 electrons that we need to get rid of, or to model, I guess we could say. All right? So if the black dot represents the nucleus, then our first ring on the inside can hold a maximum of 2 electrons. Well, we have 6. So our first 2 electrons, I'm just going to put there and there, 2 electrons. Now, it starts with 6. First ring can hold 2. So 6 minus 2, we have 4. All right, 6 minus 2 means we have 4 left. Well, that means we're going to need another ring. So we're going to draw a nice another ring. All right, our maximum energy level, or for energy level number 2, the maximum we can hold is 8. Well, 4 is less than 8. That means we can put 1, 2, 3, 4 electrons on the second ring because we have less than 8. So then we can subtract our 4. We have 0 left over. Carbon, we said at the beginning, had 6 electrons. 1, 2, 3, 4, 5, 6. We have done our rules. We built from the inside out. And then we also filled to the max and then to the next level. We filled to the max by putting 2 in the first ring and then 4 in the second ring. Okay, so as we go through with Bohr models, we're going to start practicing Bohr models and drawing new types of atoms and things like that. And what your assignment will be is it's going to look like this. All right, you'll practice a little bit. It's going to be labeled Bohr Model Practice or GAA 4.5 on Schoology. For those of you that are getting paper copies, you probably aren't watching this, and or it'll be getting sent to you as a paper copy. So you can see it says, for each element, make sure you're reading the directions and doing them properly, P.S. For each element, write the total number of electrons on the line. Then color the correct number of electrons for each orbit. Remember, fill the orbit closest first, but never exceed the number that it can hold. Check the periodic table, figure out how many electrons you can have. My suggestion is that you write the formula 2n squared at the top, that you also have your T-chart handy, and that you have the number of energy levels, and that you have the number of electrons, right? And you have 1, 2, 3, 4, and 2, 8, 18, 32. All right, just so you get into practice of keeping these there. For sodium, you're going to find sodium on the periodic table. For those of us that just know it, sodium is number 11 on the periodic table. That means that we have 11 electrons that we need to map out on our rings here, on our energy levels. So, what I'm going to do then is I'm going to take each dot is going to represent an electron. Now you can draw dots if you want to, or you can write E minuses if you want to too. That's okay. I'm going to draw dots because it makes it look nice. All right. So our first energy level can hold 2 electrons. We have 11. So we have a 1. We have a 2. All right. 11 minus 2, 9. So we have to put in the next ring can hold a maximum of 8, and we have 9 to give. So guess what? We're going to fill it up. 1, 2, 3, 4, 5, 6, 7, 8. I like to spread out my electrons just because they're easier to count. Now we have 2 right here plus another 8. That makes 10. That means I have 1 more to give. There is number 11. Quick count. 1, 2 on the first energy level. 1, 2, 3, 4, 5, 6, 7, 8 on the second level because it can hold 8. That gives us a total of 10 plus 1 more. Sodium makes 11. Hope that makes sense for you guys. Let me know if you have questions. Feel free to send me an email, or we can meet on Google Meet to get stuff squared away. Have a good day. Good luck. See you later.